Independent variable of the Cambridge-Somerville Youth Study. In the Cambridge-Somerville Youth Study, there were 600 boys randomly assigned to two conditions: to either receive treatment, and the treatment consisted of 5 years of face-to-face psychotherapy versus being in a control group. And so the independent variable was psychotherapy versus control. Remember, a variable varies. So the variable was whether or not the boys received psychotherapy or were in a control group. There were several dependent variables: court appearances, juvenile crimes, number of offenses charged, and then in the 30-year follow-up, died, age at death, evidence of mental illness, evidence of alcoholism, job satisfaction, white or blue collar work, juvenile record, no juvenile record and adult crime, juvenile record and adult crime. Anyway, you could have listed any of those dependent variables. Those were the things that are measured. So the independent variable is what the experimenter manipulates, and the dependent variables are the variables that the experimenter measures. How many got the independent variable of an experiment? Looks like most. Named at least two of the dependent variables, so court appearances, crimes charged, age at death, job satisfaction, white versus blue collar worker, evidence of having been of alcoholism or being in a mental institution, and those things. Those were various dependent variables. You were asked to name two of them. What were the results? That the boys were better off who were in the control group than the treatment group on 7 of the measures that they took, including court appearances, adult records, so court appearances as a child, crimes charged as a child, adult record, without a juvenile record, age of death, job satisfaction, if you had a blue collar work, blue collar versus white collar worker, evidence of stress-related medical diseases, and the diagnostic category if they were hospitalized for mental illness. What were the conclusions? That the difference between the groups could not be attributed to by chance. It could not be attributed to the theory that occurred due to chance, but instead that the treatments had been harmful. All right, how many got the results and conclusions there? So the Cambridge-Somerville study, surprising to people that haven't heard about it. Media is not reporting this. Media is presenting these psychotherapies, including Freudian psychotherapy. Go to the bookstore of your local bookstore, go to the psychology section, you're going to find all kind of goofy books there, with people writing up their own theories about what would be therapeutic. And then other people go there and read those books and do those therapies. Most of the therapies described in those books have never been tested. They're based on theories. Theories like the theory of unverifiable brownies. In the case of Freud, you have a theory that's basically just like the theory of unverifiable. Remember I told you, in the university you're going to be presented with a theory of unverifiable brownies. Well, you got one in this class already. You got one of those already. You're going to see others while you're here at the university. Other theories that are just like that. All right, how would you test if bloodletting is beneficial for strep? How about do an experiment? Randomly assign people to conditions who have strep. Isn't that what we did to test for the benefits of, so you take people who've got strep. That's not all people, that's a selected group of people. Randomly assign them to get the treatment or be in a control group. In this case, we want to have a placebo. So you pretend to cut them or pretend to do something else. You have some other, you give them a mojo hand, you have some other drug, so you're either going to get the bloodletting or have the other type of treatment. So you have a placebo condition and you do the bloodletting. And you see if the death rate changes or the number of days that they're sick. There are a number of different dependent variables you might have for strep. How long until they're better for those that recover, or alive or dead at the end of the study. To take a very objective dependent variable. So how many got the idea you should do an experiment? Most people, good. That's the idea. How would you check for a new psychotherapy to find out if psychotherapy is beneficial for people who are overweight and want to lose weight? How about we take people who are overweight, randomly assign them to the new therapy? The other group, you put them in a placebo condition where they maybe get books on diet or exercise or whatever the current treatment is. Dependent variable, how about weigh them in with a scale and see if the weight is different between the two groups, the average weight changes. All right, how many got the idea you might do an experiment to test the new psychotherapy? Good, looks like a lot of hands. Are there any questions about this so far? Life insurance. Joe is insured and gets strep. You advise? Take penicillin. Probably need an antibiotic. Go to the doctor. Either of those would be the doctor could decide what antibiotic might be appropriate. Fred took penicillin last year. Do you want to sell him insurance? The answer is no. Why? Because penicillin predicts death and you don't want to sell insurance to people who are going to die. But penicillin causes life. Causation and prediction are different things. This, you can cure him with penicillin and cause him to have a higher likelihood of living. But if you know that he's been taking penicillin, it's a bad sign. It means he probably was sick. People who've been taking antibiotics. So prediction and control are different things. If you want to improve the performance of students, make the class sizes smaller. If you want to predict, is this a good student or not, you say, are you in a big class or a little class? The person says, oh, I'm in a lot of little classes. You say, you're probably in special education. You'd say, don't call me special. Right? That's coming later. That's later, right? That'll happen later. We have a special program for you tonight on TV. Hey, we don't like the word special stuff. So I have a special offer for you. Hey, don't call me special, though. I don't want anything special. All right, how many got this? So this is how prediction and control are different things. The experiment tells us penicillin is beneficial for people with strep and it causes an increase in the likelihood of living. The correlational survey tells us you can use the fact that somebody is taking penicillin to predict. You can use the size of a class that somebody is in. Are you in a big class? Your English class, is it a big class? Yeah, 45 students. Oh, he's probably a good student. He wouldn't be in that big class. I'm in a class with just 6 people in it. Oh, he's a troublemaker or he's got some problem. He's in a special ed course. Right? So you can predict, knowing what size class somebody's in, how good a student they are, but you can cause them to be a better student by putting them in. Think about going to the doctor. I mean, if somebody's been going to the doctor, what are they? They're probably sick. If somebody gets sick, what do you advise them to do? Go to the doctor. Prediction and causation are different things. Causation and correlation. Correlation is the tool of the devil. Sometimes. When is it the tool of the devil? Not when it's being used just to predict, because then at least you're using it for what it's for. You're using A to predict B or B to predict A. You're using the fact that somebody's been receiving penicillin to predict that they are not going to live as long. But when you're trying to advise people what to do, then you're interested in causation. And when is correlation the tool of the devil? Well, the devil wants you to be confused, wants you to confuse causation and correlation, and think that evidence of correlation should tell you something about causation, or that evidence about causation should tell you something about correlation. And these two have nothing whatsoever to do with each other. And the devil wants you to be confused, so the devil wants you confused. Politicians are going to use correlational evidence to argue, whenever the Republicans are in power, the national debt grows. Well, that's true. That's just a correlation. Does that mean that the Republicans they cut taxes. Maybe that caused the debt to grow. So correlation might go with causation, might not. Might be the opposite direction of causation. But in politics, people are going to use correlation all the time. We need to save money by making class sizes bigger, because bigger class sizes, not only save money, but also get better performance. Students do better who are in bigger classes. And this actually was an argument in the last presidential election. All right. Those surveyed who drink 1 glass of wine a day are healthier than those. I added the word surveyed here to help make it easy for you. So this is a survey. This was not an experiment in which people randomly assigned to either get a glass of wine or not. That's different from, this one gets rediscovered and shown on the news, you know, every semester. It'll probably be shown this semester because it's a true correlation. I'll explain it to you in a bit. Those people who drink a glass of wine a day are healthier than people who don't drink a glass. But the way it's reported on the news, it's as though you should drink. And they show people pouring glasses of wine and having a social happy hour with their friends. And then they begin discussing theories. It helps you relax after work. It helps you socialize with the people you work with or that you are friends with. Or maybe there's some red good stuff that's in the wine that gives it that red color that's just good for the heart, you know, who knows? It's a possibility. Those are all possibilities. But how about a simpler possibility? Is it the case that alcoholics are less healthy than other people? Do alcoholics drink 1 glass of wine a day? No alcoholics drink 1 glass of wine a day. They either drink 0 or lots, right? So an alcoholic, as soon as you say people who drink 1 glass of wine a day, you've ruled out the alcoholics. Now how about people with diabetes who are following their doctor's advice? If you have diabetes, the doctor's going to tell you, better cut out the alcohol. You know, alcohol is not good for your diabetes. Better leave out the alcohol. Are diabetics healthier than other people or less healthy? So as soon as you say 1 glass of wine a day, you've ruled out those alcoholics, you've ruled out the alcoholics, and you've also ruled out the diabetics who are following their doctor's advice, which is not to drink. How about people who take certain medicines that in combination with alcohol are poisonous? There are some drugs that when combined with alcohol can become deadly. Would those people be advised to drink a drink of alcohol? No, it's not good advice for them. So all these people, as soon as you say people who don't drink a drink versus 1 glass of wine, we have chosen non-diabetics who are not alcoholics and who are not taking medicines that are poisonous in combination with alcohol. So we've selected a healthy group of people, and they're healthier than the alcoholics who are not drinking and the people who are taking drugs that don't mix with alcohol. And we've basically, by the question, we have ruled out a whole lot of unhealthy people. So we shouldn't be surprised that people who drink a glass of wine a day are healthier than some other people. And it would not be good advice to tell diabetics and alcoholics to go ahead and take a drink of wine, or people who are taking drugs that are poisonous in combination with alcohol. Now you might take people who are not drinking for some other reason, like religious reasons, and tell them you have to have a drink of wine a day. No, I don't want to. Oh, okay, well we can't study you then because we're not going to force people. We're not going to catch people and against their will inject them with wine. So we've ruled out religious objection. But if you've got a group of people who are not drinking for some other reasons and didn't have any of these conditions, then you could do the experiment to find out if wine drinking is beneficial. And that experiment has not yet been done. So it might be that there's a limited group of people, the ones that don't have the religious objection, ones that don't have the medical things that would disqualify diabetes or alcoholism or other drugs that poisonous combined with alcohol. Maybe those people who are choosing not to drink for some other reason, if you randomly assigned them to conditions and gave them either grape juice versus alcohol, grape juice containing the alcohol, the ones containing the alcohol would be better off. It's an empirical question, but that experiment's not been done. But this correlation has been done, but it gets presented to you on the news as if you were advised to drink. Those people that are not drinking are advised to drink because it would be good for your health. And alcoholics don't need the advice that drinking might be good for you. All right, so hopefully you did not advise people that they should drink because, as if this was evidence of causation, of a causal benefit, right? So this is not advice to drink. This is basically prediction. Those people who are drinking are probably healthier than those who aren't drinking. You could use it, you know, if you were going to sell insurance, maybe your advice might be, I would advise insurance companies to sell insurance to the people that drink 1 drink of wine a day and no more, because they live longer. Or maybe these people would be advised, be sure to save some money because you might live longer in retirement. You don't want to die and run out of money or something like that. So those might be advice you should give, but you did not want to advise people who are not drinking to drink based on this correlation, because no evidence of causation anywhere in here. All right, any questions about the quiz or the homework assignment